So the idea with with Python functions, and I can just make a little bit of text here. Python functions is that really they're the building block for logic. And so once you understand that they're the building block for logic, you can do a lot of things with a Python function. And in particular, one of the things that you can do with a Python function is get logic, right? So you can go inside and build some logic, and then at the center of this is your ability to control lots of different things from Python functions. And so what I'm going to do is just enumerate some of those things here, and we can say, for example, you can build out a like a piece of addition, for example, right? You can say add, subtract, right? That could be one thing that you do. You could build out maybe a command line tool, right? Here's another thing you can do with a Python function. You can also build out GPU logic. So if you wanted to, do highly parallelized work, it really is just a Python function. If you wanted to build out a microservice, it could be a Python function. And additionally, if you wanted to build out a new form of serverless, it's just a function. And so once you see this pattern everywhere with Python functions, you start to realize that in many scenarios, the dream thing to do is to actually build out a Python function for experimenting whether you want to go down a certain workflow. And in my opinion, you can probably spend 80% of your time, maybe 90%, maybe in some cases 100% of your time only writing Python functions. And if you need to do object-oriented programming, there's lots of great things you can do with Python. But in general, if you want to build the logic or build a solution as quickly as possible, there literally is no substitute for first building out a Python function. And so what I can do to play around with a Python function first is to go over to a Colab notebook and just start with some of the ideas for a Python function. So I'm going to go to Colab here to get a hosted solution, and then I'm going to say new notebook. And what I can do here is just call this functions 101. Right, and so one of the things I kind of like about the Colab notebook environment is it's easy to just at first almost use it as a sketch pad just to try out some ideas. And so what I'll do here is I'll put a block that says, for example, Python functions hello, and then if I do a return, we can actually see that it's going to show up in this table of contents. So if I was going to build a hello world function, the simplest one would just be this, is we could just do hello and pass, right? That's the simplest possible Python function. There's pros and cons to it. The pro to it is that it's one line. The con to it is that it actually does nothing, right? That's the downside of a Python function. Whoops, I forgot this part. Is if you just execute it in one line like this, because the pass doesn't do anything. If I want to make it do something a little bit more complex, we can do this. We can say hello here, and then now we can do something. We can just say like prints hi. And this is a little bit more complicated, but it's essentially just holding a piece of logic, and we go through here and we just say hello, right? And we're able to actually get that going. Now, if I want to make it even a little bit more complicated, what I can do, and we'll call this one hello2, just so I don't get things confused, we can actually return something as well. So we can go here and we can say def hello3, and then we can say return hi. And then in this case, if I type in hello3, we can see that it returns hi. What this really means is that if I go back to this, let's put it right here. If I go to, I say, return value of hello2 is equal to hello2, and then if I say return value of hello3 is equal to hello3, we'll be able to capture both return values. And if I look at this one, what do we have? Nothing. There's nothing inside of hello2 because it doesn't return anything. And by default, with Python, the default is none, right? So there's nothing that gets returned. It's essentially equivalent to this return value. But if I look at the third right here, we can see that there is a return value, and it's high, right? So that's really the essence. Is you can have a function that does something inside, which is a unit of work, or you can have a function that returns back something, or you could even do both, right? You could do some work and then you could return back. I personally think that this style here is generally the way to go, so that there isn't necessarily some side effect to the function. It's doing some work and then returning back the result. So let's further build on this, and let's build a hello4. So let's go hello4, but this one is going to take a parameter. In this case, it will be name, and then we can say return, and we can do basically an f string here, and we can say hi. And now this is essentially taking an input, doing something with it, and then returning it back out. And so now if I say return value of hello4, what we have is something a little bit different, and we'll just call this John here. There we go. And let's put that in there. Hi, John, right? So this pattern, even though it's intentionally extremely simple, is essentially the what's happening with a Python function, is that you're going to accept some work. In most cases, you're going to do some work, and then you're going to return the results of that work so that you can chain it together and do other things. And once you have that, then it makes it very simple to build up more and more complex things. But this is really at the root what is involved with a Python function. So what I'm going to do now is I'm going to show this repo right here, which is a new one I'm just building out, and I'll put this into the chat here so that other people can invoke it. And a couple things I'll point out is that I'm going to be using a feature called GitHub Codespaces, and GitHub Codespaces is free for anybody. You can just launch it. But one of the things I'm going to be doing in this particular environment is I will be doing a little bit of stuff with the GPU. So that is something that you don't have to use, but I wanted to show some cool things that you can do with the GPU with functions as well. But again, it's going to be this repo that I just put into the group chat. And so what I can do now is I can take this Colab notebook, and I can check it into that particular repo, which is going to pop up in a second. And then as I periodically, if I need to refer back to this particular notebook, the notebook will be checked in there. So we'll go here, and we'll just go down to this, and I'll check that in there. I think I need to add, well, it's a little more complex. I'll just actually download it and I'll put it in. That'll be a little bit easier. So one of the things that's kind of fun is you can actually just add a file directly inside of here. You can say add file, upload a file, and then I can just drag the that notebook inside of this repo, and then it'll just show up so that other people can play around with it. There it is. So what I'm going to do here is I'm going to go to code, and if you're using the free version, you can just launch your own code space. You just click this button and it'll create a code space. One thing I'll mention about this particular environment is that I am using as well like this concept of pre-builds, and the idea with this is that if I configure my environment, it will have all these installs and really complicated things happening, and then it's all happening behind the scenes. If you want to use CodeSpace pre-builds, that's a good approach to use. But the essence of it is that inside of this dev container file, I have some installation steps. In this case, this is actually allowing me to run containers that are GPU enabled inside. And then also there's some extensions here, like for example, Copilot and other tools that help me build out my interface. But you can identically copy this, just launch it and play around at the same time. So I've already got one launched, which is right here. And I'm going to just slightly tweak it based on the stuff that we're doing today. So first I'll do a get pull, since I made a small change here. I'll say get pull like that. And then I'm going to go to the README, and I'm going to tweak the README a little bit so that it's more of a README for this particular project that we're using. So this is kind of a good idea when you're building out things, is to use like a template essentially, and I'll show you that as well. If I go back here, notice that this is generated from this MLOps template. And so if you create a template, and I'll go back to this template inside of this environment, then other people can use your template. So that's essentially what I'm doing. I spent a lot of work, weeks and weeks and weeks building this environment, and then I actually can just make a new repo from this template, and that's exactly what this environment is. So I'm going to just get rid of everything in the README essentially, and I'm going to put at the very top, say, Python functions, master Python functions, and we'll say December 2023. There we go. And what I can do is just slowly document out the stuff that I'm doing, and we can say the step one, use notebook, use notebook. And what we can do is we can just point a link to that notebook that I added, which is right here. We can also run it inside of this environment, a notebook, but I'll put a link to it here. I'll say basically check out this notebook. And we'll put this as a documentation reference. There you go. So check out that notebook. Now the next thing that I think that would be important to highlight is that in order to write things really, really quickly, it's a good idea to set up a infrastructure so that you can build functions very, very quickly. And so what I would describe in order to do that is I would call this DevOps in the loop. So let's go ahead and talk about what DevOps in the loop really is. So DevOps in the loop is essentially the ability to use DevOps to speed up your ability to write code. And in fact, what I can do is I'm going to check this stuff in real quick. So we'll say get status. Let's add this to the README, and we'll say more steps here. And then I'm going to go back to this other link here, because what I can do is I can actually drop an image right inside of here, and I've actually got a really cool image that talks about DevOps in the loop right on my desktop. And I'm going to go ahead and drop this in the loop here. So we got, in fact, DevOps in the loop. Here we go. So let's go ahead and do this. So here's one that we can talk about. And we can also talk about the concept of MLOps for GitHub as well. So these will be two really, really fun topics to talk about. So the first one is, this is what I'm referring to in terms of DevOps in the loop, is that what you want to do in order to get the fastest productivity out of an environment like this, and this is kind of a new thing because of the ability to use tools like GitHub Copilot, is that you want to use traditional DevOps best practices. And what that means is that you have a makefile inside of your project, which I'll go through in a second, that allows you to do reproducible steps that the build system will do. And so this would be make lint, make format, make test. Once you set it up, you really don't have to do much to tweak it in the future. But what this does is allows you to use traditional software development tools like linting, formatting, testing, to clean up the suggestions that are coming from AI pair programming assistant. And we'll see this actually with other tools as well. So if you want to use Code Whisper, which I'll actually demonstrate a little bit later today, Code Whisper is the same thing. You want to build tools that actually allow you to format, to clean up, to test the suggestions, so that you can actually get the best of both worlds. You get the new generation of tools, which I believe will be prevalent in 2023, plus you want to actually use the traditional software development tools, and you want to do this all within a reproducible environment. And so this is what a CodeSpace does. It allows you to have a reproducible environment. AWS Cloud 9 is very similar. And then you have a tool like Visual Studio Code. Now, what this does is it allows you to use DevOps best practices, linting, formatting, testing, to actually speed up your productivity locally. And then inside of GitHub Actions as well, the build system, it will actually test the code. And the reason I'm bringing this up is that once you understand this process locally, it makes it trivial to deploy to production. And I think many people are interested in deploying to production, deploying machine learning operations type tools, deploying microservices, deploying command line tools, deploying containers. All of this is assisted by DevOps in the loop. And so similarly, let's talk a little bit about this concept of a bidirectional ecosystem for MLOps. And what's nice about this is it still corresponds to what I talked about earlier with functions. Every single thing in here essentially is a function. And what this means is that inside of GitHub, you can get these suggestions to write a function. You can test the functions. You've got this production first mindset. You can have infrastructure as code as well. So you could use tools like AWS CDK to actually build out the infrastructure for deploying your functions. And then inside of a cloud-based environment, you can deploy to an MLOps platform. You can deploy to a serverless platform like AWS Lambda. You can work with container services. You can work with compute. All of these things are enabled by this cloud-based environment. So this is really the stage here that we're going to set, and then I'm going to iteratively work through. So let's go back to this environment. And if I do a git pull, we'll see that those new images, there we go, are inside of this DevOps in the loop environment. And now let's take a look at the components necessary for DevOps in the loop. So first component is the installation tool. So one of the things that's actually been a hot topic of discussion for me personally is these like advanced installation tools. There's lots of advanced installation tools, Conda, Poetry, etc. But in reality, you actually do not need any advanced tool. You only need the Python standard library. And in fact, if you use a Python virtual environment, which I am using, which is right here, all you need to do is use the default pip tools. There's actually no situation where you need an advanced tool. If you want to use an advanced tool, great, go ahead and use an advanced tool. You are not required to use an advanced tool. Virtual environment and pip are by default installed with Python. And in this scenario, what I do is every time I make a change to my installation or I do a build in the build server, it actually goes through and it upgrades the Python default installer, which is pip, and it looks inside of this requirements. Let's take a look at this requirements file. All this is, there's nothing fancy about it, it's just the version of a package that I installed in my system, and I captured what the name of the file is or the version number, and I put it inside of here. And so what it means is it's reproducible. It means that I can reproduce exactly what I did before because that particular version is actually pinned inside of here. And you can see there's tons and tons of libraries. You know, some of these we may use today, some of these maybe we don't, but by interactively doing the installation locally and by running it inside of the build system, we can actually constantly get a feedback loop that tells me whether something works. In fact, let's try this real quick. If I just type in make install, here we go. We can see that in fact, it'll go through and it'll try to do all the installations. It should find cached requirements. You can see they're already met. So there's not anything to do other than it's going to check and see if there's a new one to actually install. Now, one thing I'll point out about this whole setup is that this is part of the feedback loop to build production for software, is to constantly be testing your installation method and also to keep it very, very simple. And let's take a look at how did I do this as well. Inside this dev container here, we have a dev container.json. Notice here that at the very, very bottom, I have something called bash setup. All this means is that when the container launches, it runs this file called setup.py, and there's nothing. There's nothing in it. All I do is I source the virtual environment that was created. And again, these are the standard library tools of Python. There's no other company I need to use, no other third-party software I need to use. This is the standard library of Python. I then echo that inside of my bash RC. What this means is that it will source the virtual environment when the environment sets up. That's it. There's literally nothing to do for Python other than to use this. And if we go to the Docker file itself and we take a look at it, this is what's building this environment. Not much is going on here. What I do is I use the GitHub recommended dev container, install a couple other packages. In this case, this enables me to use things like OpenAI Whisper. I install Python, again, the default standard library Python. I put a couple other utilities here. All this does is enable the NVIDIA GPUs inside of Docker, and then I create a Python virtual environment and copy it in there, right? So this is completely reproducible. I do not need anything else from any other vendor at all. That's it. These are the standard tools of Python. Now that I've got that, if we go back to the makefile here, I can do the other things that are DevOps best practices. So what this means is that, in my opinion, what you should be doing when you're getting these suggestions is actually formatting your code. And I'm using a tool called Python Black. And if we just type this real quick, we just type in make format, it just goes through and makes sure that if the code is messed up, it'll just kind of clean it up. And then if I say make lint, same thing, it just checks for syntax errors. And if there's some kind of a syntax problem, it'll give me a warning. Now, what I typically do, since I do this so often, is that I actually just do make refactor. So as I'm getting suggestions from Copilot, make refactor, look what it does is it goes through and it runs a lint and a test. I found that this to be extremely productive when you're building out things very, very quickly. So I just wanted to set the stage for all the tools that I'm going to use over the next few hours, so that you're able to understand beneath the hood from first principles everything that's going on. And surprisingly, even people with a lot of experience with Python are not doing something that's this simple. But in my recommendation, 80% of people in Python that are using the Python language should use this kind of a setup and only go more complex, use other complex tools if those complex tools are necessary for whatever reason. But this is the base, in my opinion, of what someone should build when they're building out a Python structure. So now what we can do is we can start writing code. So what I'm going to do is we have all these different directories here. And again, if we look at the make file here, I'm linting Hugging Face repository. But I'm going to go ahead and build things from potentially a new directory, and we'll call this function logic. So we'll call this func lodge. How about that? Func lodge. And inside of this directory, I can put some library code. So I'll go ahead and go here, and we'll say func lodge like that, and I'll put a init file here. So the idea is that I can start to build out pieces of logic and library code that I'm able to then use for multiple purposes. And if we go back to this sketchpad here, I can reuse this, right? So once I build a Python function, let's say even at the root of it, we have like an add function. This would be maybe a good one to demonstrate. At the center here, I could add on a GPU, or I could add on a command line tool, or I could add on a microservice, or I could add on serverless, right? At the heart is the logic, and then I can redirect to these other tools, and I can just make where's this arrow tool here, which I think is this. Can go to the arrow. There we go. And so it would be like this. Once you have this, you can build, in fact, build once, enjoy many, right? That's really the concept with Python functions. So let's just move all this stuff over here. So now what I'm going to do is I'm going to add this directory to my formatting loop. And so under here, what I can do is I can just add this. We can probably do that. And we can say func lodge right there, asterisk.py. And then similarly, I can add a stanza here, exactly. And so now if I say, make refactor, it should also look at this particular section. I guess if I wanted to be, more clean, I could even remove out those other things, and probably not a horrible idea actually to do that. Let's go ahead and do that. Let's just make it simple. Let's only use the stuff that we're building today. That other stuff I may or may not get to, so I can just clean this up. And you can see here how it's easy to build out a new structure for linting or testing. That's it, right? And we could even tweak this in the future as well. Make refactor, and it says pylint here. Let's try that. There we go. So we were able to lint and format. So now let's put something in there. So I would say the first thing to do inside of a function like this is to make a piece of code. And I think probably some kind of a mathematical function is one of the easier ones to play around with. And so let's go ahead and do that first. Let's go here and we'll just call this math code, like that. And then I can just click here and start building out my math code. Now here's where the fun starts, is that if you do leverage an AI programming tool like Copilot, you can actually really code much, much quicker, and you have a safety net because the refactor tool will catch some of the things. So let's try this out. So if I go here I need to prime the pump. So I need to basically tell my pair programming tool what it is I'm going to do, so it can get the prompt correctly. And I'm gonna say, build out several functions that will perform common math operations. Exactly. There we go. So what do? Well, first up, let's just there we go. It's smart enough to know I probably want something like an add, right? And it build it for me. Now, if I want to, and I think it's a good idea, immediately I would start to refactor this. So we'll say make refactor. There we go. Look, it already cleaned it up, right? So this is really the great feedback loop. Let's pretend that it made a bug here, like that. So what would I do? Look, see, it already catches the bug, right? So this is why it's so critical to use these tools simultaneously with a pair programming tool. And if I want to, I can add more stuff. We can say, and you can prime it by adding a comment at the top. You can say, build a subtract function. There we go. And so this is really boilerplate code. Do you really need it or not? That's do you really need to write this code or not? I would say probably no. And then if we want to build a multiply, there we go. And then maybe a divide and potentially, that's good enough, I think. Let's stick with that. And so now I can just say make refactor. So here's the next trick when you build out something like this is, well, what do I do with it? Like, how do I actually build other things? I would say one of the first things I would recommend is to interrogate it by using interactive Python. So if we go here and I type in IPython, now I can actually start to shape the API, right? So I can go to the Python API and say, okay, what am I building here? Let's test out this logic. So what I do is I say from func logic import add, and now func func. Let's double check why. Because I imported it wrong. So this is exactly the bug that we would flush out, right? Is that's actually not the name of the file, add. So what we want to do is say from func log dot math code import add. There we go. So I've already kind of flushed out one potential bug, and then I just say add 2 and 2, 4, right? So this is, I think, one of the funnest ways to, once you start building out a library, to actually execute it is to do that. And now all I have to do is then put this into something. And I would recommend when you're building out logic that the first step would be, after you've tested it and got everything clean, is to actually build out a command line tool. And so what we can do next is we can actually build out a command line tool for this. So I'm going to go ahead and say touch, and I'll just start to use a convention because things are so, I'm going to build so many command line tools. I'm going to say CLI, and we'll call this math code, right? So we can kind of enumerate that it's coming from this directory, and then from here I can add this to my makefile. So I can just say, okay, so we're going to do some more stuff here. So let's go ahead and do this, and we can say, woo, I don't want that suggestion. I'm going to say, it's kind of annoying that it's forcing me to do that suggestion. I'm going to say CLI mathcode.py. There we go. Although I believe it's already going to cover that, so I don't need to do that. Never mind. And then additionally, for formatting, it's going to cover everything current working directory, so we're all set. So that's always good to check that. Now I can go to this math code here, And I can also set the same prompt. So at the very top here, we can say build a click-based CLI that uses the logic in the mathcode.py. And this is really nice because it can actually set the prompt correctly. And now what I can do is I can say the shebang line, which tells this script to use things from the command line interpreter automatically, and then I can also make it executable like this. And now all I have to do is pull in that logic and very, very quickly build out a command line tool. And this will be extremely fast because I'm using Copilot, and it knows how to actually build out libraries that work with command line tools. So here we go. We can say from func log.mathcode import add, subtract, multiply, divide. Perfect. And this is going to be pretty simple because I'm going to use something in Click called a group. And what a Click group does is it actually creates subcommands for me. And so we can just follow the suggestions. And here we'll say, build an app that uses math code functions. And we could even put we can say an app, not build, because it is an app. A CLI app, the math code functions, and we even put a little documentation example like that. And we could even ask it to give me like an invocation of how it would probably work, right? It would look something like this. And so now I would just go through here and I would put in add. And this is so simple that it should essentially the code should write itself, right? Because this is really reductive. There is no skill involved with this. This is just boilerplate code. And look, it says adds two numbers. Now, and if I want to, I can actually make it you can think of Copilot almost like somebody you're working with. And you're like, hey, thanks for giving me that, but I'd like a little bit more. So all you do is say, okay, let's give some more. And then it can go through here and it can say a particular suggestion. And in fact, we could even do that here. We could say, there we go, right? We could essentially prompt it and say, hey, I want other things to be done here, right? So in this case, it's going to give all of the documentation, and then this particular tool gives some of the documentation, right? And it did that because I told it to. Now, we've been writing a lot of code. This is probably a good checkpoint to do the make format. So if I go through here and I say make refactor, we can see if anything's missing. It says, oh, look, we haven't used subtract yet. We haven't used multiply yet. We haven't used divide. Okay, so I need to build 3 more subcommands. Not a problem. Let's go ahead and do that. So we can say at subtract, and again, this should kind of build itself out. Subtract two numbers, and look, it's smart enough to kind of know what I'm going to do based on what I did before. That's exactly what I would do. Multiply, same thing. We can go through here, and we can actually build this out, and we can say multiply. There we can go divide, build this out. There we go. Divide 2 numbers. Perfect. And now we can just build out a command line tool. That's it. And because I already did the chmod plus x, it should be trivial to test out. I would just go through here. Well, first let's refactor, double check, is all my code clean? It's perfect. Great. Now I can just say I can run it. So I can just say clean math code help. There we go. We see all the different options. In fact, if I pull this up, it even shows me these different options. I could clean that up if I needed to. Why not? Let's make this a little bit cleaner. Let's do that. And there we go. That's a little bit cleaner. And now I can just test it out. I can just say add 2 and 2, 4, divide How about 100 by 2? There you go. And we could also do multiply, test that one out. Multiply 2 and 5, 10, and then we could do subtract. Let's see if it'll fix a subtract bug, give us a negative number. Oh, it does, not bad. So we have a nice little calculator here, and I'm gonna go ahead and check it in. So get status, get add. And because I have a build system that is checking all this stuff, it should also build this, it should also do the test of the system. And that's what this particular piece of code is right here, GitHub Actions. If we look at this, it's doing all of the same things that I did locally here. And we can go back to this repo, and we can look at this actions here, and it's going to build out, in fact, a test here and verify that actually things work. And what we could do as well is we could go to this CI pipeline here, and we could say create status badge, and we can actually just get some insight into this build process in our README file. In fact, I'll just put this at the very top, and so that other people can see, hey, my code actually has been validated. So this is really the essence of the building blocks, in my opinion, of Python best practices that will just supercharge people's productivity. And it's a new type of a workflow that's emerging in 2023. So the next thing that I'm going to do in our journey is go back to this environment and take a look at what else you can do. So if we again look at this function logic here, it's inside of a directory called init.py. We have math code here, but you can build more than one kind of command line tool. And if we scroll down here, we see that in fact we have the CLI math code, which was actually very easy to build. But we could try to build another command line tool that is slightly different, uses a different framework. And so let's go ahead and try that. Let's go ahead and build one called with Python Fire, which I don't know if I have it loaded, but it's easy to load. If I go through here and I look for Fire, yeah, so it's not loaded. So I'm going to go ahead and search for it. Python Fire. Here we go. So this is made by Google. This is also kind of a cool little tool. And so Python Fire is a simple way to create a command line tool. So what does it say? Okay, Python install Fire. Okay, let's do that. So let's go ahead and put this over here, and we'll put Fire inside. Now, take a look at this. I'm going to go ahead and put this into DevOps section of my requirements file. There we go, Fire. Now, how would I install this? Let me just show you how I personally do it. I just say make install, and what it'll do is it'll look through all my requirements and it'll find like the new one. In this case, it'll be Python Fire, and then it's pretty easy. There we go. So it's installing 0.5. Now, how do I pin this? I just say pip freeze grep Fire, and I just put this inside, right? So we know that in the future, I should be able to use this. That's it. Pretty simple process. That's why I don't understand people using really complex tools. This is very simple. So next, I'm going to just create a file that will be similar to this other CLI. So let's go ahead and do that. We'll say touch, and we'll call this one CLI math, or CLI Fire math code.py. So this will be just a little bit different, but close. And so we can go ahead and refresh this. There we go. And we can put the prompt as well. So we can say, build out a command line interface for the math functions in math code. And we can put uses Python Fire to build a CLI. And this will hopefully allow the the pair programming tool to help us build out suggestions. And I'm pretty confident. I've actually not used it with the pair programming tool before, but I'm pretty confident it'll be very good. And so I can say from, there we go. So it helped me do this prompt, and then we can do main. And look at this. This is not a lot of code here to build out a command line tool. And that's what's kind of cool about Python Fire, is that if you have the logic already created, it can just essentially ingest it with probably the lowest amount of code possible. And so how would we, I believe this is correct. We have this fire.fire main. It's possible that there's bugs, but let's go ahead and refactor first. And let's make sure that actually works. So it looks like it's potentially going to work. And I'm also going to chmod it here. And now let's do fire help. Whoa, that's pretty cool, huh? So you can see here that it essentially just builds the logic for us. And now what I can do is I just can say add 2 and 2. There we go. So if you wanted to build the world's simplest command line tool that uses the least amount of code from logic that you built, this is pretty tough to beat. There's pros and cons to both approaches, but if you're going to be building, let's say, I don't know, maybe like an SDK for something, and you're just, coding really, really fast, this might be the tool to use to document an API, for example. So really, really cool tool here. So now let's go back again to refactor. So double check, looking good. And let's go ahead and check this in. So we'll say get status, get add, get commit, adding Python Fire version. Now there is something that we're missing here that is probably something you should do in most projects, is have a little bit of tests. And so it's debatable whether you need to invoke the command line tool to test. You can, or whether you just focus on the logic. I would say that that's the most efficient way to test. And so what we can do is I can build a test out really quick. So if we say make test, for example, notice that I'm not testing that other tool here, right? And so I need to actually add it to my file. So if I go to test here, notice that we're running these tests for these two libraries. I'm going to add another one, which is the func logic, right? Which is coverage equals, and it's going to be func log, func log. Okay. Let's make a test, and it should say 0, right? So there's no testing at all inside of this. So to fix this, we can just create a test. We say touch test, and we can get into writing a test for this, and we can say, in fact, func log.py. And here's again where Copilot is pretty amazing, is if we go to our test function here, which is right here, this is one of the best use cases for a tool like Copilot, in that what it does is it actually can build out the test for us. So build out test for func logic math code, func logic, and we'll say, how about all of them? So we probably don't need PyTest. We could, but I'm going to say from func log, and then basically the tests essentially get written for me. So why would I not do this, right? This is great, right? And so we can actually get full test coverage just by doing that. And then I can again say make refactor here, which I think it might clean up the test function a little bit. And then we can actually say make test now. And so we can see that, in fact, I've now got 100% test coverage, which is awesome, right? So this is a very robust way to build things out. And I would say you can test the command line tools as well, but the biggest bang for your buck is gonna build out the test for the functions that you build out inside of your library. So let's go ahead and add this again. We'll say get status, get add, all this, get commit, adding make file, or adding testing for logic. So where can we go from here? So we've built out some really neat little command line tools. I think the next step would be to go a little bit further and actually take the same style of code and build a web service out of it. And so it's pretty easy to build a web service for something using some kind of a framework. And in fact, there's a couple different ways that we could approach this. The first thing I'll do is I'll just make one called web. We'll call this web math code, like that. And let's see, let's just use the same style. Yeah, web math code. Let's try that. And then again, I can refresh this, and we can close all these things to make it a little bit cleaner. And let's take a look at what we have installed inside of the requirements. Do we have a web framework here? I believe let's look for Fast API. We do. So we have Fast API. Now, since I'm working on Fast API and there's nothing necessarily new in here, might as well just unpin it for a second and actually get the latest version here, Fast API and UVcorn, and let's actually install again. So say make install. Perfect. It's going to go out, reach into Fast API and UVcorn, whatever the latest versions are, and then I'm going to get those latest versions, and then I'm going to put them in. So let's go ahead and try that. Let's say pip freeze grep Fast API. Here we go. Perfect. That, I don't know if that was the same version I was using or not, but who cares? We're just double checking here. UVcorn. There we go. And we'll also grab that and put it in there. Perfect. So now we can build out our tool. So let's go to web math code, and we can just say at the top here, we can say a small microservice. Well, look how smart Copilot is. So we don't want to use Flask. Uses Fast API. So we have to, and UVcorn. There you go. So we really do have to be good about the things that we're building. So all I need to do is import the logic, and we can go here and from Fast API import Fast API, and then we can import as well. We can say from math code, we have these library functions, and now we can actually really quickly build out a microservice using Fast API. And so one of the things that we can do is we have to help it prompt a little bit, and so we can say, like, build out routes for each import, right? Imported function. Pretty smart, right? So now it's going to know, oh, that's all I got to do, and look, there's not, one of the nice things about Fast API is that it's just so simple to take logic and put it into a piece of code. Look at this, trivial to do this, right? And we do that, trivial, we do that, divide, and now we just have to invoke the app, which should be the if under name. There we go. and we can say host would be, we can just say 0.0.0 .0, and we should probably say port 8000. I like port 8080 personally, because it works with a lot of defaults. And now we just say Python web math code, and it says, no module named math code. So we have one problem, which I could have figured out by looking at refactor, because refactor, the nice thing about this is that it can catch a lot of problems for us that were suggested. So this is not perfect, if you remember. So what we need to do is we need to say from func lib dot math code. I believe that's the way that we want to do that. And we can save this. Wait. Okay, and we can do this, make refactor, and what did I, oh, func logic. There we go. Yeah, I'm not sure why that thing is acting weird like that. I'm going to just close it and open it back up again. There we go. That looks good. Now let's go ahead and refactor this. And so now we see there's only a few more bugs, and we can just say, well, yeah, so what's happening here is that we should add something to the top of this, like, like maybe we can just say add route or subtract route or multiply routes or divide route, right? That could be a good way to do it. And yeah, not sure why that's acting strange like that, but we can do this. There we go. So now everything's clean, and now if I just go through and I say Python web, look at this. Now I can preview it, and here's the beauty of using the tool Fast API, or the framework Fast API, is if I go to docs, check this out. I don't have to do anything. I can test out my application, and we can go right in here and just start playing around, right? To execute. Look at this. And if I want to, I could even get this curl command and invoke it. All, really, really simple way to test out your code and your API. So the tools that we have available for us are truly amazing. Basically, they're really shocking how well we're able to actually build stuff out, all using really this logic scenario where we put stuff inside, and then we use these high-level tools to do all the heavy lifting for us. And then it's not that much more difficult to then deploy this to a production environment, which I'll do a little bit later. So let's go ahead and check all this in, and we can say get status here, and we can say get add web math code, and we can say Fast API service. There we go. So pretty cool that we're able to do that much stuff that quickly. So this is a simple example, though. Let's actually build something a little more fun that will be less about kind of toy apps, and let's try to build something that's a little bit more realistic. And so what we would need to do is go back to this func logic here and actually try to build out some other kind of thing. So one of the ways that we could do this is we could go first to the Python, the PyPy location here. Look, it says find, install, and publish Python packages with the Python package index. You could look at like trending projects. So we could see things like There's an API, high energy physics. You could kind of go through here, play around, look for projects. Like the one I like to play around with a little bit is Wikipedia. Here we go, Wikipedia API. You could search for things. There's other ones that are kind of fun, like GeoPy is another one. So you just have to, use your imagination a little bit to play around with different things here. I would say the Wikipedia could be a good one to play around with, because it's a nice it's a nice place to start in terms of prototyping stuff. And so what we could do is we could look for keywords inside of Wikipedia, and I think that would be a good one to play around with. And so I'm going to go ahead and say we'll say func logic, and we'll call this wiki news keywords, like that. So wiki news keywords. And if we go into here, we can refresh this wiki news keywords. So what we could build out here is something that can find news from Wikipedia and then get us some keywords as a result, maybe even hashtags. And so let's go ahead and do that. So we'll say we're going to build out a library that finds news from Wikipedia and returns the top keywords from the article. Yeah, this looks pretty good. So to start with, we would say import Wikipedia, and let's double check that I've got it installed. And let's go to requirements. Let's look for Wikipedia. So it's not installed, so I need to install it. So let's go to, we can call this section, we can call this like text tools here. So you can see Yake is a keyword extractor, and we could also put Wikipedia in here. And so again, really simple process. What do? The same thing I've been doing the whole time, make install. It's going to go ahead and grab the latest version of Wikipedia and put it inside of here. And let's go ahead and find it. Okay, now what we can do is we can say pip freeze grep Wikipedia, and we've got Wikipedia version, and we just throw it in there, right? So that's nice. And now the only other thing we need to do is start using this library. So we can actually say import Wikipedia, and now we can say get wiki. So get the top 10 keywords from a Wikipedia article. Now, does it do that? I don't know if Wikipedia does that. Let's try it out though. So this is where it's good to use IPython to toy with something you have, and also to do refactor. So I'm gonna say make refactor. Just first, does anything work? And looks like there's a problem. So look, it gave us a bogus suggestion. And so what we need to do is fix this a little bit. And we need to actually be a little bit better at directing it. So we can say build a, what I don't know actually is, does Wikipedia have an issue or not? Now, it is looking like this environment, something's acting a little bit strange here. So one of the things I'm going to do real quick is I'm going to just reboot this. So this is a good thing to know about if you ever have issues inside of your environment, is you can always just close it. In this case, because it's a code space, I can actually go to this environment here, and I can look at my code space. There we go. And I can actually go ahead, if I wanted to, I could even stop it because it was acting weird. And then I can actually launch it again, and it should just basically reboot itself. So you can control it and stop it, and if it's acting a little bit weird, you can always like even destroy it if you want to, because all of my code and my logic is inside of another environment. So I shouldn't really need to do anything for this to work. So if we go back here, we can actually look at the pre-builds. So if I go to CodeSpace pre-build here, I believe that it was successful at one point. So I should be able to, I could even completely destroy this environment if I wanted to, if it's acting weird, which is great. This is one of the strong use cases for this. So let's see if this works. Restart. There we go. So it stopped it. And look, restart is immediate because it's already been pre-built, which is, I think, one of the really cool features of this. And if this still had problems, I would just delete the entire code space. And because one is pre-built, it'll just launch it again. So, sometimes you get weird bugs like that overwriting bug. Who cares? We can reproduce it because it's a reproducible environment. So let's double check whether that happens again or not. I don't think it will, but if it does, we're prepared for it. Let's see what happens if I just save it. Doesn't look like it's acting weird anymore. It just looks like it just needed to be rebooted. So what I need to do is get a better prompt here. I'm going to say build a. Well, first let's look at PyPy, and let's go to Wikipedia, and let's see if there's like a news feature somewhere inside of here. So we can say quick start Wikipedia documentation. And is there anything for let's see, get a Wikipedia search suggestion for a query? If no, oh, that's interesting. And search, I guess we need to just play around with this, right? So look at this, GeoSearch. Do a GeoSearch for latitude, longitude. So it is important to get a random list of Wikipedia article titles. That's interesting. I like. So I think we can work with this. So I think the first thing I need to play around with is that I should look at search, and if true, returns results and suggestions, if any. So let's compare the difference between these two. And in fact, I don't even need to build anything out yet. I can just use IPython. So this is where IPython is a huge tool for trying new ideas out. So I just want to say import Wikipedia. Look, I can play around with this, and the doc said Wikipedia search query. So let's do a query, and we can say, I know the hot thing in the news right now is FTX, right? Like, are they going to indict, or they have indicted? Are they going to do something with that founder? And let's see if we can find some stuff about it. And we can do this. We can say Wikipedia search query results suggestion false. What do we get? There we go. Look, we have all these suggestions here. Now, what I don't know, what happens if I say suggestions true? What does that do? So it just puts like some extra suggestions in there. GTX. I don't even know what that is. But this, let's I don't know the difference here. Is it that the suggestion is the last one? Maybe that's too tricky for me to handle. I want to keep it simple. And I'm gonna start with search. And so we can start with that. So we can say like here's the search, but I want to get the page now. So we'll say bankruptcy of FTX, for example. So we can say page equals, and let's just grab one of these results here, something like that, and we can say Wikipedia dot page. I'm assuming this is how it works. Wikipedia dot page and we just put in page. Oh, there we go. Dot content. There we go. So we can get the entire content of a page very easily. So we can just build out several functions. So build out return, build a function that returns the results of a Wikipedia search. Right, so that's easy, right? There's not much there's not much to do, and in fact we're just almost wrapping something that we don't even need to wrap. But for the sake of building functions, let's do that, and then we can build a function that returns the entire content of a Wikipedia article. And so in this case, search term, we should be able to, that looks good. And then let's get the top keywords from an article. But what we need to do is import this Yake tool, because Yake can do this. And so returns the top 10 keywords from using Yake. And so is it smart enough? Yeah. So this Yake tool can get the keywords out of here. So the way to try this out, since we know that this term is actually good, the bankruptcy of FTX, what we should be able to do is just pass that in there. So let's just copy that, and let's get out of here. Let's say exit, and we'll go to IPython, and we'll say the import here. So from func logic dots wiki news keywords import all. And we say who, that shows us what's imported. And now we can just say page is equal to, which we can get the auto completion from IPython here, and then I can say result is equal to wiki keywords, and then that page. And we look at results. There we go. We've got the keywords out of here. So kind of a cool little service inside of here that we've been able to find, and we could do all kinds of fun things with it, and I don't know, build out other natural language processing things like sentiment analysis, or entity extraction, all kinds of really cool stuff. But we can start off with this first, and it looks pretty good. And we can go back now to this and just say make tests. That looks good. We could add some tests in the future. We could say make refactor. And so now it would be pretty easy to just build this into a command line tool. So what we can do is build this out into a kind of the same style that I did before. We'll say CLI, and we'll call this wiki news, or wiki keywords, .py. And then we can go into here. We can do the same prompts. We can say from. Now it's a good question. If we want to move quickly, the quickest possible way to build this out would probably be Python Fire. But if we want to build something that's a little more like nice and pretty, we can also use the click. So we'll just say, you use click to build out a CLI for Wikipedia, Wiki News keywords. Okay, and so we'll do the same thing. We'll add a shebang line here, like that, and we can say chmod plus x here, and we can say import click. We don't need to import Wikipedia. We just need to say from this. I like that it shortened it. It's a good suggestion, actually. Let's go ahead and do that. And then we can just build out a click group to build a click group. So you got to prompt it, and we could do example. We can say search for keywords in a Wikipedia article, and then we'll do example here like this, and wiki keywords search Python. Or we know that there's another one we could do, wiki keywords search FTX bankruptcy. There you go, like that. And let's go ahead and do this. So we'll build out search. So this will be the first one. So we can just search anything in Wikipedia. And by we should, I would say, do a default, which so type would be string, default would be FTX bankruptcy, because we know that there's a result for that, and we can put it inside of here. There we go. That looks good. And then we can also build out a, we can do keywords that for the keywords. There we go. Here we go. Search term, FTX bankruptcy looks good. And we can say return now. Now here's where I would want to prompt it a little bit. So first, I'm going to add some documentation for this real quick. We can say example here, right? So there we go. And then I also can add an example here. Example, there we go. But I'm gonna actually make it a little bit fancier, and I'm gonna do a limit. And so I want to limit the amount of keywords. Exactly, default. But let's just do three keywords. And could we even tweak it a little bit and say, return the top limit keywords in color green. Sure. So there's the keywords for keyword and keywords limit, and we can do that. And we can build out basically invoke it, and there we go. So we don't need to do it like that. We could. Oh, that is interesting. The way that they invoke it like that. Sure, let's do that. And let's go ahead and I think I already chmoded it, but just in case, wiki keywords. Let's run it. Wiki keywords help. There we go. That looks good. We can also do a make refactor real quick. Just double check it and put any bugs in there. Cleans it up. We see some warnings, which in an error. Look, we do have some problems. So let's fix this real quick. So we have line 41 is keywords. We just changed this to CLI. Whoops, CLI, like that. And then also limit 42, because this needs to be passed into this limit. There we go. Right. So refactor again helped us find bugs, undefined variable keywords, which is on line 49. Oh, because it's now keyword CLI. There we go. Make refactor. Perfect. And now I can say get status. It looks good. Let's check all this in. Git commit, adding CLI. Push that. And now let's test out our tool. Help, that works. If we look for keywords, by default, it'll do the FTX bankruptcy. There we go. So the 3 top keywords are FTX, November, and Alameda Research. So at least the first 2 make a lot of sense, or the first and the third, like FTX and Alameda Research. Those are the 2 places that were invoked in there. Now, if I wanted to put a new keyword, we could put in Enron, for example, and so Enron didn't match. So we could probably clean things up. I don't know, fraud, or we could add new things in here. There we go. So this is showing us kind of results of different things that we could search for. Straight out of Oz. I don't know what that is. Let's put that in there. The 3 keywords. There we go. I don't know exactly. It must be some kind of musical or something. But basically, we're able to actually use this pretty quickly to build out solutions here. So the tool for using cloud-based environments for AWS is something called Cloud9, and that's actually kind of a fun one to play around with if you want to build out things in a cloud-based environment. Another option for building out serverless-based things is to just directly use the console in AWS. But let's go ahead and use both. So the first thing that I'm going to do is I'm going to create a new environment, and we'll call this Python functions. And we can put a documentation here that says, Python functions using Cloud9 and Code Whisper. So AWS does have their own code pair programming tool as well called Code Whisper, and we can actually play around with it. And I'm gonna go ahead and select the large. This looks like a good machine to use, and just say create. So it's going to go through it. It's going to create this large environment. And while this is running, what I can do as well is click it, which says Python functions, and it will show me this preview window. So if I want to use some of my same code here, I would have to actually do only a very, very tiny amount of changes. One of the things I'll have to do is actually add, this environment is not available. So this particular machine was not available, which does happen sometimes, which is kind of weird. But what I could do instead is create a new one. We'll call this one Python functions 2022, and we'll call this Cloud9 plus Code Whisper. Do it again. Yes, sometimes you get this. There could be like an issue with a lot of people using a particular type of instance. It would be great if they told you that beforehand, but one of the ways you can get around that is to just pick a different one. And probably, I don't think a lot of people are using one of these large ones. So I'm going to grab, like a 16 gig 4-core machine. Let's try that. M4 XL large, and let's see if that one works. If it doesn't work, I doubt it won't work. But if it doesn't, I could always just use one I've already got created. So we'll let this thing spin up for a second. I will need to go to GitHub to add the keys so that I can actually build out in this environment. And we can actually do that by opening up another window to go to my GitHub account. while that's spinning up. And I'm going to go to settings, SSH and GPG keys, and create a new one. And we'll call this cloud 9 functions. And if we go to this, to this environment, we'll close that one. There we go, successfully created it. So great, it was able to create it. So we're all I need to do now to port my code over here is just type in SSH keygen -t RSA, and it will print out this key. Let's go ahead and do that. And let's go ahead and put this into this environment here. It's going to ask me to put in some codes here. So I'm going to go ahead and do that. And we've got, let's see here. Let's try it again. Add this. I'm going to go ahead and add this in here. For some reason, my GitHub is not exactly working. So I'm just gonna pull this into another screen for a second, and I'm gonna just do like a two-factor auth version, and we'll do it that way. Okay, I was able to get that in, and that the key's in there. So now all I have to do is go to this repo, say go to repository, it'll open up a new one, go to code, go to the SSH section here, and copy that. And now if I go into this environment, I can just say git clone, and we just clone this into this environment. So pretty straightforward actually to use Cloud9. That's the only thing. There's only one other thing we need to do, which is pretty simple, which is create a virtual environment. So again, this is where I know there's a lot of, I think, misinformation out there about the Python standard library. Python standard library includes every single tool you need to install packages, to work on things. Here's a great example. If I just type in Python 3-m venv and I create a virtual environment, this is included in Python. You don't need to download some other tool from some company or from some other open source project. If you want to do that, great, but at least understand how it actually works, which is it comes with Python. We create Python virtual environment. Now, if I want to invoke that Python virtual environment over and over again, what do? Pretty straightforward. All you have to do is you could actually copy this into your bash RC. So let's go ahead and go to bash RC here, and we'll go to the bottom, and we just put in, each time I open the shell, source virtual env, right? So really simple process here. Source tilde.venv, bin activate. Never again do I have to worry about it. I'm all set. There's a one-to-one mapping for this particular cloud-based environment and what it is I'm doing. How can we verify? All I have to do is this, new terminal, right? And inside of this terminal, look what we have, virtual environments. And if I say which Python, we can see this is installed. If I say which pip is installed. There's nothing to do. There's no other tool we need. If you want to use other tools, great. You do not need other tools other than the Python standard library. I'm trying to evangelize this as much as I can because there's a lot of misinformation out there about you need some other tool like Conda, like Poetry. If you want to use those tools, go for it. You do not need them. Okay, so next I'm going to go into here and I'm going to say make all. So what make all will do is that we can go to the make file and look at this. What does all do? Installs lints test format deploy. Now deploy, there's nothing yet. We will get to that in a second, but there's no deploy step. Let's just say make all. What happens is it's going to go through, it's going to install all those packages. So this is the other really amazing thing about this particular environment, is that it should be pretty straightforward to figure out what's going on here, unless there is a bug with a installation. We can debug this very simply though, because it does see that there's an error here. It says, look, ignore the following versions, blah, 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 no matching distribution found for Python 1.5, right? So there's some kind of weird problem with a dependency that we don't even care about. So pretty easy to fix this though. Let's go ahead and fix this. So it's saying pandas. It looks like it came from Jupyter 1.0. So how do we fix this? We just go here and we find pandas and we just take this out, right? So, and we take this out. So far I haven't even used these libraries and I may not even need to use them. So I could just punt, but for fun, let's put these back in. How do I fix this? I just say make install. And this should grab whatever the latest version is of these two libraries. Now in this case, it says no matching distribution found for NumPy. So these three libraries are, I call this the JCPenney's suite, which is Jupyter, Pandas, and Conda. Those are typically packaged together. They can really cause a lot of problems because of weird things that they do. But in this case, I should be able to get through this by just unpinning it, picking up the latest versions. There we go. So now scikit-learn has got a problem. We can just fix all these. In fact, probably all the data science libraries are all jacked up, and we can just fix all of them very simply by just rerunning this particular installation right here. So it's actually kind of a good exercise to see this. Of course, I haven't even used these libraries yet, so I could just, if there's a problem, just dump them, because we don't. Here we go, MLflow, right? We have another one. So you do get this sometimes, and this is the advantage though of using like pinning and unpinning and all that kind of stuff, is that you can get feedback, right? The feedback tells you exactly what it is that you're doing. In fact, I'm going to just maybe get rid of MLflow because I know for a fact I'm not going to use it right now. But let's see if this builds real quick. Okay, it's collecting torch. Looking good here. It's installing this. What this could also highlight is that it may be a good idea to remove some of these dependencies because I'm not really using them for now. And so that's what I probably will do if there's continues to be issues. I mean, we're installing a lot of things that I haven't yet used, but let's see if this finishes here. Okay, like NVIDIA stuff, for example, which I think is coming from, I don't know where that's coming from actually. Maybe that's coming from PyTorch or something like that. Look, so I installed so much software, there's no space left on the device. So this is fortunately a pretty easy one to fix. If we just go to resize Cloud9 here, we can find this script that one of my friends wrote, and we can just copy it, and we just go here and we just resize it. Whoops, we can do this. So the script essentially just runs a bash command that will resize our environments, which is right here. There you go. Now we can resize this thing. Perfect. And then if we just do df-h, we see that there's tons of room, right? 53 gigs now available, because I think it resized it to 60. Just go again, make install. So it's actually great to see little weird issues happen in a different environment, because it shows you how you don't need specialized tools. You just need the Python standard library to fix, I would say 99.99999% of problems. You don't need other tools. Start with a standard library, start with requirements, start with virtual environment, and you can fix almost everything. And here we are. We're able to install just a ton of tools here. This is probably one of the most complex setups for different collection of libraries you could even consider. And in fact, we have no issues. And let's just leave this going here, and we can see that it looks like it's getting close. Now it's installing some NVIDIA stuff. It would be kind of neat if Cloud9 was able to do GPU. It does not have that capability yet, which is something that would be nice to do. Okay, now it's doing TensorFlow. Again, we have just an amazing amount of libraries here, and we're able to get through even weird, complex dependency problems by using the Python standard library. Okay, installing. There we go. And perfect. Looks like every single thing was able to be installed here with pin dependencies that we were able to fix. Now it's doing this last thing, installing a few other things. There are some warnings here which we don't necessarily care about. And here we go. I think it's getting to the end, right? Because I think it's Wikipedia is maybe the last installation. So we installed 47-ish, in the late 40s packages, which it's unlikely that most Python projects would even have this much. And these are very exotic tools, some of them, and still we don't have problems. I think that's the amazing thing about just the regular Python standard library, and why it is a great tool. And one of the things you can do to debug things, if you can say top and just see what's happening. Look, we see pip is still cranking right here, and it's set up as installing Wikipedia. Not sure why Wikipedia is taking that long, but you can always, if you're having issues, just do the top command and take a look at it and see why it's hanging, which it is strange that it's taking that much time for just Wikipedia. We could also double check. Oh, there we go. It looks like it's diminishing. It's getting done. Now, oh, there we go. Whisper. It's installing this. The other thing you can do that's kind of fun when you're looking at like a huge install like this is that you can also double check the version of Python. So it's 3.7. So 3.7 is kind of an old version. That could be, I think it's actually being deprecated. So that could be an issue here. Why the installation is taking, there were some issues earlier. That newer versions of the Python probably would be better. But regardless, we're able to, it appears, get everything working, right? So we got everything working. Now, one tool I do like to install that might as well install in here is sudo yum install htop. And htop is kind of fun because it's just like a slightly fancier version of top, right? So you just get a little bit better view of like the different cores and how much memory is available and things like that. And it, depending on what it is you're doing, building containers, etc., it can be useful to build. So we're all set. we got everything installed just as I expected. Now let's take a quick tour of this cloud-based environment and show why it's so helpful for building out functions in Python. So one of the things we can do is go over here to AWS. If we select AWS, it actually has surprisingly a lot of little tools available. So one of them is this. See this right here, Code Whisper. So it's essentially equivalent to AWS Copilot, although it's in preview. It's not fully baked out, so there could be some weird issues with Copilot, but we can use it there. There's also developer tools. So if we wanted to deploy our application to like a AWS Lambda using CDK, we could do that. In fact, we may have time to cover that. And then as well, we can go to other parts of AWS like Lambda, and we can just make a function right here. We could create a Lambda SAM application and edit it locally if we wanted to, which is actually pretty cool. So maybe we should start there. Let's go ahead and do that. Let's go ahead and say create SAM application, and it's going to ask us what runtime to use. Now here, because we're already inside of a 3.7 environment, my recommendation would be to use 3.7, and you can choose image here, and we can just say a basic hello world application, and it's going to say, well, where do you want to put that? We can select right here, and we can call this thing something. So we can just say like Lambda. Let's just call this functions or func Lambda. How about that? Func Lambda. Let's do that. All right. And so this will now build this out locally here inside of my application. And look, we can see here that it will include some documentation as well about how to actually deal with this in terms of deploying it, documentation, etc. And this is all in the README. So great, thanks for doing that for me. Let's go back to our Explorer here, and let's look. Here we go, Func Lambda. We have another application here, and what we can do is see that there is a whole environment here for us to play around with. Let's go ahead and read the README here. So let's go ahead and take that first, and we can see here that it says this project contains source code. There's a hello world that has the Lambda function and the project Docker file. There's the events here that allows us to invoke it. There's unit tests also inside of here, and there's a template .yaml as well. And so it even walks us through step by step all the different things that we would need to do. So it says to build and deploy for the first time, we'll just do SAM build, SAM deploy guided, and then it will basically use infrastructure as code as well for us to build this out, which is really, really cool. And so to build your application with SAM build, you just say SAM build, and we can do all this stuff, and you can even invoke it locally. So this is kind of cool. So one thing I'm going to change though is that because I'm going to be building out this inside of this environment, I should potentially tweak things a little bit here because we have a separate set of requirements, right? And so I believe it will talk about that in the toolkit here. It will say something about that. It will say about the virtual environment. Here we go. It says the pip install PyTest. The tester defining the test, use pip to install it. You can find more information. So it does give us some clues here that, you know, depending on what it is we want to do. Now, because this is a specialized environment, I probably would want to deactivate my virtual environment if I'm going to work in this one, which is pretty easy to do. We can just do this. We can say deactivate to deactivate a virtual environment. And then I can CD into this Func Lambda. And from here, I could more treat this like an isolated environment. And in fact, inside of the hello world here, this is really the gist of everything that we have. And what I can do is actually look at this requirements to see what's in here. It's just request. If we look at the app here, we can see actually the function. So we're again to the point where a function is all that's necessary. And you can see that the event is a dictionary. The context is shows you like the runtime methods and attributes, and you can actually return this with an API gateway if you want. But this is essentially just a hello world type function. So I'm gonna clean this up a little bit because I don't want this to be a lot of code. So I'm gonna just delete that, and we're just gonna say we're gonna make a Marco Polo function, and we'll just do Marco Polo lambda, which is kind of a fun one to play around with. Is all I need to do to play around with this one is I just need to say if the event name is equal to Marco, return back Polo, otherwise just return back no, right? So we can keep it really simple, right? Like this is a very, very simple lambda function. And I don't even know if we need requests, but we can put it in here. I don't know why we would need that. I'm actually not going to import that. Let's just do this. But basically, now in order to invoke this, what I should do is I should actually do a pip install the way that they're telling me to do the pip install. So let's just close a bunch of things up here, and let's actually follow the guide that they're going to tell me. And so the guide that they're going to tell me is we can do this. It says this project contains source code, blah 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 blah. The code for this will differ based on the runtime. Now, I guess I could actually activate my virtual environment because I don't think that it's going to hurt me to activate it. So I'm going to go ahead and do that again. All I need to do to reactivate is just say, just type in bash, right? And then we're back. And so you can see here that we can go to this one, this README, and we'll just follow step by step what it wants us to do. So first step, we're going to type in SAM build like that. There we go. So it says template not found. So I need to go up one level, SAM build. And there we go. So it's going to go down. It's going to pull a Docker container image. It's going to pull a Docker image that will allow us to invoke this within this particular environment. And that is one of the cool things about using containers, is it lets you do essentially invoke things in this particular environment, and we see that it actually pulling these requirements there. So I can use this requirements file here as the thing that's going to get installed, right? There's not a lot actually that's going to go on there. And now the next thing, look, it says the commands you can use next. It even tells us we could invoke it if we wanted to. And let's do that. Let's what happens if we do that? We can validate the SAM function. So we could say SAM validate. Looks good, right? And then we could do SAM local invoke. So it's going to go ahead and invoke this thing, and it says, now we would need to pass in a payload here. Let's see if we can copy a payload. Here we go. You would do, I see, you need to give it the events that live in here. This events.json, right? And you could actually pass in a payload here. Now this is like the complexity around that is a little more than I want to deal with. I don't want to deal with that thing. If you needed to, you can, but I'm just going to deploy it, then test it. Although so we could curl it, right? We could do it that way, but I think it would be easier to just deploy it because it's not very complicated. So let's just do this. We'll do SAM deploy guided, and we can do this thing. There we go. And setting the default arguments, we can call this one a Marco Polo December 13. And we just go through. It says confirm the changes. Yes, we want to deploy. Yes, we want to give it permission. No, we'll just yes, we don't care. It doesn't need to have argumentation. Save the config file. Create manage repositories for all functions. There we go. So it did have one issue here, which it says managed repositories will be deleted. Looking for resources needed. A different default S3 bucket can be set. Image repository is not found. Managed repositories will be depleted. Create manage for all functions. So maybe we could do it one more time, and this time don't say yes. So we'll just say Marco Polo 13 2022. And we can just say I think I can just actually say default. May not have. No. Oh. You have to just play around with these real quick. Marco Polo 132022. Let's go through here. Confirm changes before deploy. Allow IAM role. Disable rollback. No. And we can say, yes, it's okay. Save arguments. Yes. Yes. No. So we'll try that. Maybe that will fix it. ECR repository for Hello World function. So maybe because that was an issue before, what I could do to hack this is I could go to ECR real quick, and we could go to this and make a new one real quick and call this Marco Polo 2022. Let's see if that works. There we go. And we can go back to our environments and say Marco Polo 2022. Does that work? Oh, it needs a different URI. It needs the actual URI here, which is annoying, which is this one, which is the URI. Hold on, Marco Polo. That one. It's going to need that URI. So go back one more time. Go Marco Polo 2022 or 23. There. Confirm changes. Yes. Okay. Last time. Create it. No. Let's try that. There we go. So it took a little bit of back and forth here to get this working. So it should be pushing this to this container registry. And so if we go to this here, it will once it's deployed, and it should be fast because it's in the same data center as AWS Lambda, it should be able to push this into this environment. You don't have to use this method. I mean, you could just go to the console and just play around with it. The advantage of building it like this is that it's actually reproducible, and that you could put in all of the dependencies, all your code in here, and build it in a container and test it out locally. Now, this did have one problem: failed to create update. The error occurred. So anyway, there's some issue in deploying it this way. Not 100% sure why that issue is there, but you don't need to even do this, because you can also just go to Lambda and do it yourself. So we can even just look at the code here and we can just steal this code. Basically, we just grab this. And let's go to the console real quick and go to Lambda, Lambda here. Yeah, and deployment always has weird stuff that happens, and who knows what the issues are. We'll call this MP 2023. Let's do that and just make this function. I find myself, if I do need to write lambdas, a little bit gravitating towards the console for prototyping, just because those weird issues with like sending everything up are lessened a little bit in first playing around with this. So again, I just do this, right? I just go Marco Polo and I could deploy it. It's trivial, a lot quicker than what I was just doing. Configure a test event. We'll call this Marco. And I could just put in the name here, Marco. And if we save it, we test it out. There we go, Marco Polo. Right, so we got this thing working. Now, what is cool is I can go back now to this environment, and let's just close all this stuff. And this is maybe like kind of a fun thing to do, is if I go back to this here, one of the things that I can do is I go back to AWS, and if we look, in fact, for, what did I call this thing? I called it MP203. I think I might need to refresh this, and I don't remember how you refresh it, but let's just do that. Let's just refresh this thing, go back to this Explorer, find Lambda, and we should be able to see that Lambda, right? And I can just invoke on AWS. You don't have to create it locally inside of here. You can actually just play with it here, and you could just say hello world like that, and we can do the same thing. We can say name here, Marco, and we can invoke it right there. You go. And if we put in a different name, we can see that actually. So I think personally that's one of the quickest ways to just really quickly build something. Now, one of the things you can do though as well to play around with this, that's kind of fun, is if you go here, you can actually download it, which might be a quicker way to build it actually. As we saw, the default way is a little clumsy. If we go to this, look, it's downloading it into my environment now, which is pretty cool. Look at this, MP, there we go. And so I can actually just play around with it right here. So there's pros and cons to each approach to building functions, but a trivial way to build it out is to actually use the default tools that are available. Now, the other thing that you can do that's kind of fun with functions once you start going into the cloud is there's another service called step functions. And with step functions, you actually can very easily create a state machine and actually invoke that function that I just did earlier. So if I go here and I just grab this invoke, we could actually like wrap it all up into a nice little system here. We can just say like, basically call Marco Polo here. We can go to the Lambda, which would show up right here. We can say MP2023, and that's it. We can just invoke it. And now this is kind of even a cleaner way to do this, because we could actually just say next. We could even check this into our project if we wanted to. We'd just say next here, and we just call this MP2023 step, whatever I want to call it. Create the state machine, and now it's trivial to actually just put a payload inside of here. And we can just try this real quick. We can say name, and we can just say Marco, and this will invoke it. There you go. And if we look at the details, we actually can see that it was able to be successfully called, and we can look at the task was successful, right? So we have really good instrumentation here. That's the reason why this is kind of fun, is that we can actually see everything, the step details inside of here. Let's refresh it real quick. It's acting weird. If I click on this here, we should be able to say start, finish, execution succeeded. There you go. There's the output. And we could say execution started, and look, here's the input, right? So we can completely 100% reproduce this. Even further, what we can do, that's pretty cool, is that we can, I believe, invoke it from here. Let's see if we see step functions inside of here. Step functions, yep, there we go. And we can look at the, let's again refresh this page real quick. And then let's go back to AWS, and let's go to step functions. And what did we call it? MP20223. Let's go ahead and say start execution. Again, trivial to do. We just do this, right? We just say name Marco. And you could obviously chain lots of lambdas together. And there we go. Execution started. And we could go back to the lambda or back to the step function, and it should show us, there we go. Another one has actually just been invoked. And if we go to the input, it might even tell us where it came from. I'm not sure if it will tell us that. But anyway, we did a different one inside of here. The other thing that we can do that's kind of cool is we can also just do it from the CLI. So we could say AWS step functions and do -- help. And can we even invoke it? I believe step functions. Let's look at the docs real quick here. Let's go to this documentation. Let's go over here. And installation, we're updating the latest versions of the CLI, and we can do a search for step functions CLI. See if we can find some docs on this. Using the examples, there should be AWS step functions command line. Sometimes Google is better, and we can say list state machines, and let's see, which version is this? You're viewing older, so let's look at to view the page for the version 2. We'll go here. So list state machines. So we should, I think, be able to just do that first. So we can do list state machines. There we go. So we can list all the different state machines available. And then to invoke it, if we want to invoke it, let's go back here, and we want to say available commands. I think it would be start execution. State machine start execution, and the name of the execution, or the ARN. I think it's just going to need that. And then the input, the string that contains. So we can essentially create this. So we can say step function, and we can do the first part, which is the state machine ARN, which is that, which should be this one right here, MP, the state machine ARN. So it should be that here. And then we have to do the payload, which we know should be Marco Polo, which should be that. So something like this would be -- input. The string that contains a JSON for the execution. I think it's going to be something like this. We would say name Marco, and we would do dash input. Something like this. If I don't get it right, not too worried about it. I think, is it this? Error, invalid choice. Anyway, it's something similar. You can also invoke it. I always have to Google it and debug it a little bit. But the nutshell is that you can completely build out functions in a command line environment using AWS Cloud 9. All right, so this is a good place for a break. When I get back, what I will do is then shift over to deploying microservices using what we built earlier. And so I'll show how you can actually package this up with a Docker container, build out your whole environment using a cloud-based tool, and then push that into production. And then you have full working continuous deployment for your system. All right, let's take a 15-minute break and be back then. Oh, oh God. Oh man, hilarious stuff. Here. Yeah, so I would say basically a lot of the principles, the stuff covering the principles of DevOps is included. A lot of these same concepts are in fact covered in my latest book. Okay, we have some questions here that I'm going to push to the slide area. First one is, I'm new to Python and I was unsure of how the bracket colon limit worked. So the idea here is that with Python lists, you can slice them. And so you can basically pull the front of it off or the back of it off, or you can slice a range from a list. And so since the items were coming back as a list, it's an easy way to get the limit is to just do a slice of that, right? So the first 5 items would be the limit of 5, or the first 10 items would be a limit of 10. And so that's a nice little trick to know about in Python. You can read about the slicing of lists in the Python documentation. Okay, so next question here. How much of what you're showing today is in the book we're reviewed for prep? So a lot of the build script type things are actually covered. So if you go to Python for DevOps book, or if you go to the practical MLOps books that I've written for O'Reilly, those I do cover quite a bit this concept of reproducible environments. The current book that I'm writing, which is implementing MLOps in the enterprise, is also going to heavily cover code spaces and some of the things that I'm covering now. And so I do have a little bit of that actually built into the rough drafts that are put on to the O'Reilly platform. So yeah, I would say the last several books I've written for O'Reilly all have variations of this inside of there. Okay, next question here is that it looks like you're using Visual Code on Linux from within a Google Chrome tab. Is that correct? Yeah, so that's exactly the point, in my opinion, of why this environment is so amazing, is that you only need a Chrome tab. So you could have a very low-powered computer. You could have a Chromebook, right? You could have, extremely weak computer, but the cloud-based resource itself is running very powerful things like $5,000 GPUs or 16-core machines or whatever it is that you need to do. So this is really the advantage of using the cloud-based development environments. And of course, you can do it from anywhere, right? You can be in a coffee shop, you can be at the library, you can be at school, you can be at work, and you can just quickly bring up your environment. So I think there's just so many advantages to using a web-based browser to develop. And you can see things are just getting better and better. And it really is the standard, I think, that a lot of people are using for doing development. All right, great questions here, and keep them coming. I'm gonna keep moving down with functions here. And so what I also wanted to cover is that, we built the function with the AWS Lambda, but you can do the same thing with the other cloud platforms. You can do it with Azure. You can do it with GCP, right? They're all great places to develop. In fact, let's start with GCP because it's got one of the more fun ones to build functions with. And so all I need to do is just type in cloud functions inside of GCP, and it's a very similar process. We can go to create functions here, and inside of here, we can choose between the first generation or the second generation. I guess I'm always a sucker for the latest version. So let's build on the second generation, and we can just call this whatever it is we want to call it. Now, what I could do is actually reuse a lot of the code I already wrote. So why don't we do that? Let's remember what we called our other function over here, and let's actually just essentially crib this code from this environment. I think it was like wiki keywords. So let's do that. Let's build this. We'll call this wiki keywords. Oh, they must be lowercase and hyphens. Okay, so we'll do that. We'll say wiki keywords. There we go. So wiki keywords. In fact, we don't need a hyphen there. That looks good enough. Wiki keywords, and we're going to do unauthenticated invocations, and we're going to go to next here, and we have to pick the runtime. So we can pick anything from .NET, Go, Java, Python, PHP, Ruby, a lot of stuff here. We're going to pick Python, the latest version, Python 10, And here's where things get a little bit more fun in some sense, in that this environment is, I think, a little more straightforward for building things with dependencies. And notice again here, look, there's just requirements. So you don't need fancy tools. We don't need to install some super fancy like third-party installer. You just put the requirements inside of here, and look, this has this particular setup here. Now, a couple things to point out is that I can actually run this and edit it within Visual Studio Code as well. And we could try that. That actually might be kind of fun. But first, let's get something working. And so this is going to use the functions framework here. So let's just get rid of this stuff, which I just don't want. We actually can tweak this a little bit. Here's the entry point, hello HTTP. I guess that'll work. And so now I just need to copy some of this code, some of this logic here. So I would just need to go to this thing and go to the wiki keywords here. And we could just put all these in there like that. We could just do that. So this will definitely make things more complex. And let's throw that all in there. So we got that, we got that, we get that. Now requirements, I need to then follow my requirements. So let's go to that requirements file. And we can go to these two tools here. We can put those like that. And we go back to this. And so I think all we would need to do is we could keep it the same. If request in JSON, we do that. And so we would just take that payload, and that would be the search term essentially. Now this will be a little bit trickier because when you're in an environment like this, it's not great to build out code because of spacing. It's a clumsy environment, but we could look again at our example here, and we could do something like that. And we could say, I think something like this could work. So if we go back here, we could say keyword. So it's going to be something like this. This code is so convoluted that I might even need to just build like a GCP example or something like that here, local example, just so I can get a proper editor, because it could really be tricky to debug. And so here we go, GCP example. So at least so you can see it's like just a mess, right? So I could say, make refactor here. In fact, I could even get some ideas here. So it says cannot parse line 35. Yeah, just as I suspected, like there's all kinds of weird formatting issues with all this stuff, like definitely annoying to deal with this kind of stuff. See, this is super annoying. Here, we can go there, we can delete this, we can delete that, and then we can say for keyword and keywords, I don't know, like what do they typically want you to do inside of this? They want you to maybe like return keywords, maybe, or just return keywords. How about that? Just return keywords. How about that? So if I do a format, will it format it for me? So still got a formatting error on line 29, which is this one. So is the issue... It looks better. Make refactor. There we go. Undefined functions, undefined variable. So, and so this would be wiki keywords. We don't need that. So that was not helpful. We were able to figure out some bugs here. And then the name would be, this would be search term, right? So this does help us quite a bit to build this out. Now, again, I can't actually install this and do it locally as well, which I've done in the past, but function frameworks, unused request args. So yeah, I don't think we need that. We can get rid of that. And we can do one more time. So it's only missing this functions framework, which I guess I could install. If we go to this, I think it will tell us, if we go to the functions framework, GCP, I think it'll show us how to pip install it. Cloud functions here. Go to quick start. And they should tell you how to do local development. There we go. So local development, and we go to Python. There we go. We just installed that. So we can go to this real quick, do the requirements, file, and we can put this, maybe web, we'll call it web. And we can just say make install. So we can test it in both locations. We can test it out in here, and we can test it out inside of GCP. They both seem fun. And I guess we can pin it once I've got it installed. So pip freeze grep functions framework. There we go. So we just put this pinned version here. Writes into that. There we go. Looks good. So now that I've got this example, looks like it probably works. If I do a make linting it, or actually make lint, sorry, kill that. A make refactor. There should be no bugs. Yeah, no bugs in this code. So I can just grab this entire example here, paste it into here. In theory, this should work. In theory, let's see here. So I'm going to deploy. Now, while that's deploying, why don't we also test out the local version so I can read the documentation again, which is going to be, where was that documentation? Running functions, here it is. Let's go to this documentation. And so it tells me all this, So it says, do you replace this with your method's name? So functions framework dash target with your function's name. Calling the local function. So calling the function directly. Running functions framework. So it looks like it's something like this. It looks like calling local functions. I don't 100% understand how to do it. Maybe I don't need it. Let's first see if it'll deploy. And if I need to run it locally, I will. But I probably do not need to run this locally. So it's going to build this cloud service. And once it is deployed, which it is, in theory, we should be able to test it by clicking on testing, and we can pass in a payload, which in this case, I think we knew that FTX was a search term. Look, it even gives us this curl command. And so we can test it out in Cloud Shell, which is pretty cool. So it lets us test this out just using a curl command right here. Oh, it already did that. Whoops, let's close it. Let's test it again. So I guess it injects it. There you go, automatically. I would be surprised if this works. I'm always skeptical of my code, but we're about to find out. Yeah, didn't work. So we can debug this thing by going to the logs, and we should be able to see why there was an issue with it. Unknown error. So text payload. So it's hard to unsupported system call. Is it very likely you can safely ignore this? Wiki keywords. So it says wiki keywords, labels, error detected in wiki keywords. JSON payload, error events. Here we go. What does it say? It says resource. Hard to know. Error detected, error events. It's not giving me good logs here. It's a little bit tricky to figure out. So maybe this is too complex. This might be too complex of a script to just throw in there. We could download it though, and I'm just curious if I download it, what it will give me. I can probably throw that into our. Just downloads the file. So let's try to get it running locally then. So I had some issues, and according to this, you can do this. You can say frameworks function target with your functions method name. Now, what I don't see here is before running a function using frameworks, you need to specify both the type and the name of the function that you want to call. So let's see if we can figure out how to do this. It says cloud functions, running frameworks, HTTP functions. Here we go. Here's our code here. Next steps. Here's a tutorial. And deploying. You can deploy it there. Triggering the function. So you can also trigger it with Gen 2 here, and you can format it. So yeah, I guess there's a bunch of different things we could do to debug this. I mean, we could start with if request and name is equal to, we could basically either do a hello world or just start again. Let's start again for a second. Let's just make a new one that's just a hello world, and we'll do generation 2. We'll call this HW2 unauthenticated, and let's pick Python 3.10. And in this case, we should just be like, again, it'll just take a payload called hello world. Let's just get that working. That's how I typically would debug something, is does anything work? It should just take a second to invoke it. and we can look at the details here. Look at the source code, which is kind of nice. We can look at the variables, see if there's anything inside of here. The trigger, in this case, to be web, the logs, and the testing. So while that's deploying, I could just really quickly try to run that other command here really quick. I know for sure I could look at if it would be nice if they showed me the documentation in GitHub. And that's what I'm going to try to find out real quick is GitHub. Here we go. So we've got Cloud Functions Framework Python. This is what I'm caring about. So, okay, we do this. It says this. Quick start. So here's a hello world. Oh, so create a main.file with the following content. So let's try this out locally inside of our environment. Let's literally copy this example. So I'm going to say make dir GCP func like this, and I'm going to cd into there. And now I'm going to say touch main.py. So it looks like it does need to be called main.py. And then if we just copy this example here into that, like that, we should be able to do that. Right, so we should be able to say functions, target hello, debug, and does it work? So yeah, it does work. That's pretty simple, right? Not bad. And then what else does it say to debug it? Is that you can curl, quick start. Yeah, they're really easy, and you can curl like that as well. So where things get a little bit more complex is if you need to post, which we would need to do. So in this chart, cloud event function, you a cloud event parameter, and so that's another way to call it. Error handling, pub sub. So this has got a lot of really cool stuff for you to build it inside of here. But let's go back to this thing really quick to test it out. So we can say test out in Cloud Shell, and it's going to do hello world. And not sure why that's not showing up here. Post method. Huh. Interesting how it actually didn't put the commands in here inside to actually test it out. I can refresh it real quick and see if that fixes it. But you can invoke it in this console here as well. You should be able to. So, there we go. So finally it did it. I don't know why that wasn't showing up. And if we invoke it, there we go, hello world. That works. So we know hello world works. Where it gets more complex, and we see that that's the payload. So we could probably get our other version running locally. If I'm brave, I can try it. So we know that it looked like this. So let's grab this here. Let's kill this, and then let's go back to this main here. And let's just throw it all in there. And what do we got? Import functions framework. And then if we run it again, target would be hello HTTP. Here we go. So what's wrong with this? There's some bug in this code. We might be able to figure it out. Well, local variable search term reference before an assignment. There we go. So that might be the issue. So search term. Oh, so if request.json, well, in that case, though, that's because we're not sending it a payload. And so we would need to do another terminal here, and if we copied the other example like this and we just tweak it a little bit, it should look kind of like this. So let's go to this environment here. We'll just call it like curl it .sh like that, and we just tweak it a little bit. So we know it's going to be, instead it's going to be localhost 8080, right? So we would be curl post localhost, and I think the framework told us this. I think it told us, right? I think it said, yeah, localhost 8080 like that. So we can go back to this localhost 8080. We don't need the authorization, and we can just tweak this to be FTX. So in theory, this should smoke out the bug, if there is one, inside of here. So let's go back to this and let's type in bash curl it. The page GTX does not, so there's some internal bug here in the Wikipedia call, and I think we can figure this out by, what did we put in our command line tool here, which was CLI. We need to fix the default query. There we go, FTS bankruptcy. That's the issue. Instead of just FTX, we need to do FTX bankruptcy. So let's try that. Okay. Now let's run this. There we go. So we just had a bad query. So in fact, what this is telling me is that the deployed version would probably work. And so all I would need to do is grab this, go back to my deployed function inside of the GCP cloud, which we go to cloud functions, we grab the wiki keywords right here, and we go to testing, and all we need to change is this, is we need to pass in FTX bankruptcy. It's going to give us this curl command. We test it in the Cloud Shell. Fingers crossed. And boom, we're able to deploy. So you can see how the cloud, once you start building the logic for a cloud function, or start building functions, you can deploy to all these different kinds of environments. So that was actually pretty cool. Now, all I need to do is check in this code so other people can see it. So I can just do this, get status, check all this in. Now, probably the funnest thing to do, adding GCP versions from here, would be to also show how to do it with Azure, right? So we can also do it with Azure. So how would we do this? Well, one of the ways that we can actually do this is by going to function inside of Azure. So it's got the same kind of capability. And if we go to function app, we can just go through here and we can just say, hey, let's make a new thing. Let's go ahead and create a new function app. And we can take a look at some of the things that you can do. So we can create a name. We can call this keywords, and keywords December 13. And now we can either do code or we can do Docker container. For code, I'm going to select Python and operating system Linux. Let's go to review and create. Here we go. Now here's where the Visual Studio Code is also our friend, because what we can do here is actually pull this in to our environments inside of code spaces. So this thing's actually, triggering all this stuff. While this is running, I'm going to go back to code spaces. I'm going to get this in the same shell here, and I'm going to go to extensions, And so this one says reload required. Sure, let's reload this. But we're going to install Azure. And so notice that inside of here, this is Azure App Service or Azure Functions. And Azure Functions extension, I believe it's this one. And let's double check here what it does. So to create, debug, manage, and deploy. So you create it, HTTP triggers, you attach it. Yeah, I think this is the one that lets you invoke it all locally. So let's install this one. And I believe what will happen is that it will ask me what I want to do once it appears. So this looks like it's enabled. Let's refresh real quick. Let's just make sure that appears. It should appear down here. There we go. So we see it now. We have there should be Azure. There we go, Azure. So we would want to sign in to Azure. It's going to ask me to sign in. You can close this window. Now I can go to this environment and I can find my Functions app. And we should, once it's done, okay, go to resource. I believe we just go to Functions now and you say create. And we can say where we want to develop. We want to develop in VS Code. And so let's go ahead and close that. And let's go back here. So I think I can right click, create function app in Azure. That's what I believe that's what I want to do. Let's refresh here real quick. There should be another one. There we go, keywords, that's the one. Here we go. And now here's the functions. And so I forget here, this might not be the right tool to do this installation. There's another extension that might be better. I'm not 100% sure yet though. Let's see if we say plus, create function app in Azure for serverless. I don't know if it's that one or whether you create it here in portal or here we go, HTTP. I guess I could just start with this and I could always pull it back in. There we go. So I deployed a HTTP trigger, and then we've got code and test, and then you could go in here and you could actually build it out. So we see we've got this kind of a similar environment than GCP. And if I do go back again here and I refresh, so let's just escape this, and I refresh this, there's our trigger, and we can actually see everything that is inside of this. And I think as well it should have the code if I wanted to go through there, and if I wanted to build it out and test it all and do the same thing. So really in a nutshell, the concept of once you build a function, you can easily take the logic and actually deploy it to many different kinds of environments, and it's actually pretty trivial. One other thing that I'll show you that's similar to this, if we go back to the GCP cloud really quick, is in addition to the cloud functions, there's kind of like the next rev up, which would be something called Cloud Run, and it's also kind of identical to this in that you can build out a containerized service that again uses similar logic. So there's a couple ways to do this. One, I could just create a new service. A second one is if I go to Cloud Shell, this is kind of a neater one, is they've really been working on this editor here, is that I could basically use their fancy interface that has a cloud native environment and also build out a containerized microservice. So let's go ahead and see how that would work. If I click on this, notice what happens is it's got Cloud Run right here. And if I click on plus, create a new Cloud Run app, it'll ask me what kind of service to build. Let's build a Flask app, for example. And it'll say like, where do you want to create this? We'll go ahead and do this, create a new application. And what it does is it creates an entire environment for me to do the customized development. Now, they don't yet have the pair programming type tool. I would be curious when they're going to get something like this, like either Code Whisper or Copilot, but it shows you exactly how to actually build this out. Look what they've got here. So they've got an app file, right? Really, really easy here. They also have a Docker file right here. And notice the Docker file that they use is very simple. You know, we have some simple things that we go through here and we build. So what I could do, if I'm brave, is I could see if I could port my code over here and see if I could get it to work really quickly, or I could just deploy this, either one. Probably I'll just deploy it because the time is running short. So if I go through here to run this, you just say run, you go to here and you just, I think it says the emulator. So you say, click on the Cloud Run status bar and select Run on Cloud Run Emulator. So I believe it's status bar here. Where is it? Here we go. Start with out debugging. And I believe it will just run it locally for us. If I remember correctly. Launch and debug. This one. There we go. So we're able to go inside of here and we see it's running, et cetera, et cetera, et cetera. Right. So the other thing that we can do that's pretty simple is that once we go here, I believe it created those files, Hello World 1, that if we go inside of here, one of the nice things about this style, like if I just look at the Docker file, is that to deploy it, I believe it is just called GCP Cloud Run Deploy, if I remember correctly. And let's look at the documentation real quick. Cloud Run. I think it's just one line. So quick start. Let's look at the documentation. Quick start, build, and deploy. If I remember correctly, that's all you got to do. That cloud space or gcloud space run space deploy. So if we go back here, if I just do that command, and again, it's not a lot of code, and notice this does highlight what I talked about earlier, which is that functions, right? What is this? A function, right? So we're just deploying a function into production. So let's go ahead and do that command, gcloud run deploy, and it's going to say source code, sure. Service name, sure. Ask for a numeric number. How about US East 1? Let's do that. And we can say that. And now we just deploy this thing into production. So once you've got some logic as a function, you put it into either some kind of microservice framework like Flask or Fast API, you have a Docker file, the whole world opens up to you. There's just really a ton of different places that you can deploy your code to. And that's really the advantage of using Python functions, right? Is the ability to take logic and make it go live. And we've been able to do that in 4 different environments. AWS, we've been able to do it in GitHub, we've been able to do it in GCP, we've been able to do it in Azure. We've also been able to do it in slightly different versions. In this case, we're not only using Cloud Functions, but also using Cloud Run. There's a lot of really cool things that you get by actually doing this. So we can see it's in action here, and it's doing a deploy. I mean, it's really amazing actually when you think about it. It's just one command. There we go. Hello world is up. We can just go to that URL, and there we go. And we can see successfully running deployed a container. Now, I believe we can debug this thing on the fly. If I remember correctly, it's pretty trivial to make a change. So let's try that. Let's go into the app here, and let's just tweak this a little bit. And we can say the message is it's running, and I changed it, right? And now if I say deploy, it should let us redeploy easily. Let me Google the docs here. Listen, so you can deploy blah 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 to Cloud Run. I believe the redeploy should be simple. Wait, redeploy Cloud Run should be easy. Cloud build. Cloud Run app. Deploying to Cloud Run. Build again. Well, I don't need to necessarily Google it. I'll just run it. Right, let's go back to, where is it? Here it is. Let's just go back to US East 128. Let's see what it says. Hopefully, it's a pretty easy process. Oh, to make this the default region, we could do that, right? So we could say, so I will do that. That might make it easier. Is equivalent to doing this. This command is equivalent to doing Cloud Run deploy. So there's probably a way to make this, the source code, next time you use to deploy the current directory. So we could do that. We could say gcloud deploy source. And let's just see how quickly it is able to make a change. So pretty fast, actually. So let's run this command too, so it remembers that. Let's go to this, and it says it's running, and I changed it, right? So you can see it's trivial to redeploy. So I mean, I guess I have a few minutes. In theory, I could get really wild here, and I could go to the editor, and let's just make all this smaller. And I'm curious how far I could go. So if I went to my code here, and I grab one of my other microservices, like the this web one that I had, this one, like this. Yeah, this would be a good one. This should be, let's build one in Flask real quick, and let's just copy it over. Let's go to function log. So let's just grab all this. Let's put this in here. So we can do this. And we could just make a quick little add function here. And we could just say, app dot routes, and we could do add, and it would be and I always forget how you build out the routes inside of Flask. We could be lazy and we could just ask our friend here, Copilot, touch web add Flask. Let's see how fast it can build it out. And we just say this, build out the, and we can say from this, so first though, I need to just paste in this stuff. From Flask, there we go. And then we can say build out the Flask app. There we go. Add the routes. Let's see what we can come up with. Post method. What if I want to say, I don't want to do a post, I want to do this. And we can say add, and I say forget if it's like this syntax, and we want to say, we want to do a get method. Get method, build an add route with a get method. Let's try that. Let's see if that'll help us. That takes both numbers as parameters. No, as URL parameters. I don't know why this is, I'm struggling with, it's not giving me the best. We can just say Flask URL parameters. Let's see what we got here. Requests. Flask. Oh, there we go. That's what I'm curious about. We want something like that. So that's what I thought. Okay, so we'll go to this, and we'll just say A and B, something like that. We'll go back to our code here. We'll just say A and B. There we go. That looks good. Add A and B. There we go. So that's all we need. We need that. So if I go back to this, I throw this inside of here. We can get rid of the other stuff. We don't need it. Whoops. Delete this, delete this, delete this. In theory, this should work. We stop this. Control C to kill this. Well, we don't even need to preview it. I can just go back to the terminal. And I can go to the command that it told me earlier, which was this. And this should take at least some of it away. If I remember, it's going to be deployed to 28. So we'll go here. Service name, that's good. Wow, didn't have to do anything. I just needed to. So it should be picking up that change that I just made, and fingers crossed, it'll give us the new routes that are available, and that should allow me to make a third deployment of this service. All right, we're fingers crossed here this will work. I guess you could also look at the logs and see how it's doing in production by looking at the logs as well. Okay, building the container. Creating revision, deploying revision, routing traffic should be next because it just checked the health. All right. Does it work? It does work. And if I say add 2 and 2, it works.